Hello, I'm Shine. Welcome to my channel. Today, I would like to share how to create Real-Line plot in our statistics software. Firstly, I want to explain what is the Real-Line plot. Real-Line plot is a similar data description with a bar graph. That's what created with AZ. Which variable is higher, which variable lower in the plot. However, the Real-Line plot is different in data visualization and data presentation. Therefore, real-line plot is advanced level data presentation because if we show the data with a bar graph, we can see only the average data value in the figure, and then we can see which one is the highest, which one is the lower Biden treatment. We cannot see which one is the higher and the lower within treatment. Real-line plot can show the data frequency in the plots within treatment, such as the highest blow, the lowest value, and the data accumulation also. Then we can see the data situation also. Data is stable or otherwise data is normal variation like that from the red line plot. Therefore, I mentioned red line plot is an advanced level. That is better data visualization than a bar graph. Therefore, I want to recommend using a real line plot instead of a bar graph. To create a real-line plot in our statistics software, we had to install two packages. They are ggplot2 and ggridge. But if you want to put the index or significant value between the treatment, we had to install one more package. The name is ggsignificant. But today I will show only the real-line plot by using ggplot2 and ggridge without or including significant value. Today I will show with example data for real-line plot. Firstly, I will call data table in our statistics software by using a function. My data is about the collected temperature data from 3 cities such as Yangon, Mandalay, and Minchin. According to my data, there are two factors, city and temperature, and then there are 7 replications in each treatment. In here, we had to know one thing. If we want to find a significant difference between each city, the data should be at least 7 replication. In my data, there's a 7 replication. Therefore, I can find the significant value also. But today, I will not show the significant value. Just I will show only the real line plot and what can we see in this real line plot. If we create a bar graph in AZ, we will get this figure according to my data. We can see only the average value or each city. We can compare between treatment according to the average value. That's all. We cannot see how is the data frequency, where is the data accumulation, what is the lower value, what is the highest value within treatment. However, we can see this kind of data presentation in the real line plot. Now, I will show the function to draw real line plot. Firstly, we had to write a ggplot and then we had to put our data table name. If you give other name in your table, you had to write the name that you give. In this table, I give the data table name is data. That's why I put the data. And then whatever we draw the plot or bar graph or any plot, we had x axis and y axis. So therefore, temperature factor will put in x axis and city factor will put in y axis in this real line plot. And then geodensity gradient. That function is for drawing real line plot with gradient color according to data frequency. Now I will click Ctrl R to get the real line plot. Now we got the real line plot. When we look at this picture, we can see how much is the lowest, how much is the higher, and temperature frequency of the city, temperature frequency of each city. And then we can get the higher temperature having city. And when we look at the plot generally, as I mentioned, when we make at the bar graph, we cannot get the data frequency within treatment. However, if we look at this Ridgeline plot, for example, we can check in Mandalay, the temperature of Mandalay has no marked variation. That is stable temperature because Ridgeline plot is only 1p. 1p means that this data frequency is stable. If we look at Minchan city, this temperature or city is not much stable because Ridgeline plot has 3p. That means that the temperature is not stable. There's a variation. But the temperature is stable between 10 and 15 degrees Celsius because between 10 and 15 the peak is higher. That means that data accumulation is higher in there. But sometimes the temperature can reach around 15 and 20 degrees Celsius according to this Ridgeline plot. According to this plot, the temperature of Minchan is not stable. When we look at this city, the temperature of Yangon is not much variation, but this temperature also can change sometime. So, according to this Ridgeline plot, we can see the temperature of Mandalay is stable, Minchan temperature variation is too high, Yangon temperature is not much stable and not much variation according to this Ridgeline plot. If we take the bar graph, if we make the bar graph with AZ, we can see only which city is the higher, which city is the lowest, like that. But if we create a Ridgeline plot, we can say how much the higher temperature, how much the lower temperature, how much the data frequency, how much the data accumulation, and then we can compare between city also, and then we can say data situation between the city and within city. So that's why I want to recommend to use the Ridgeline plot by using the ArcStatistics software. Today I show how to draw the Ridgeline plot by using the ArcStatistics software. So thank you. See you next video.